Alright, the last section of this part before your quiz is all about splitting your data up into different pieces. And then we're going to use those pieces to make box and whisker plots. This is the ultimate goal. A fractile, think about like fracturing your arm. When you fracture your arm, you split your arm into multiple pieces. You split that bone up. A fractile in statistics is splitting up your data. It's numbers that split up your data. So your median is a fractile because your median is the middle number. You line all your numbers up, and the one in the middle is the median, and it splits your data in half. Okay, so the median is a fractile. We're going to actually use 3 fractiles today to split our data up into 4 parts. And the things we're going to use are called quartiles. Now, the word quartile makes you think of 4 because quart is 4. But there are only 3 quartiles, which might sound a little bit confusing. But if you think about it, if this is our data all lined up, you have your median, which splits your data in half. Then if you look at the lower half, you have quartile 1 that splits the lower half into 2 parts. And then you look at the upper half, and you have quartile 3 that splits that into 2 parts. So when you're done, you have 1, 2, 3, 4 sections, but it only took 3 chunks, 3 lines to split that into 4 sections. So the lines are called quartiles. The one that splits the lower half, this lower part, into 2 is called quartile 1. The median, the one in the middle, is quartile 2. And then the one that splits the upper half into 2 parts is called quartile 3. So those 3 numbers split your data up into 4 different pieces. So the first quartile splits the first half into chunks. The second quartile is your median, and then your third quartile splits the second half into 2 pieces. We want to find the median or the second quartile. Quartile 2 and the median are the same things. We find that first because it's easier to find the middle and then find the middle of the bottom half and the middle of the lower half. So you find the center first, your median, and then split it up from there. So in order to do that, you have to put your data in order from smallest to largest, just like you did when you just had to find the median. So you split it up, or you put it all in order from smallest to largest. You find the median first, so you split it in half, and then find the medians of each half. So you look at the lower half, cut that into 2, then look at the upper half and cut that into 2. This was the data that was given to us, so we have test scores. And you start by putting it in order. So I went from the smallest number of 5 to the largest number of 37. Once you have them all lined up, you start crossing them off to find the median. So just like you did before, you cross off one at the bottom and one at the top, all the way through until you have found a number that's in the middle. That's our median, but the median and quartile 2 are the exact same thing, but you find that first. Once you've found that, you go to the lower half and you start doing the same thing. You start crossing numbers off in the lower half until you find the number in the middle there. The number in the middle at the bottom is quartile 1 or Q1. Then you go to the top and do the exact same thing. Cross the numbers off one at a time on the top half until you find the number in the middle, and that is Q3. So you literally just line it up, find the center, and then find the center of each half to get the quartiles. So my quartile 1 is 10, quartile 2 is 15, and quartile 3 is 18. Those specific numbers split our data up into 4 different pieces. The interquartile range, or IQR, takes these pieces from Q1 to Q3 and it finds the difference. It wants to know how much is in between those two. So to find the IQR, the interquartile range, it wants to know how many numbers fall within these quartiles, Q1 and Q3. So you take Q3, the bigger one, and subtract Q1. So in our case, Q3 was 18 and Q1 was 10, and 18 minus 10 was 8. So the interquartile range was 8. So 8 numbers fall within that middle part of our data. And it seems kind of pointless to find, except for the fact that the interquartile range is what helps us find outliers. It is pretty simple to look at data, that's kind of crossed out, but it's pretty easy to look at a group of data and say this is probably an outlier. But there has to be a mathematical reason why something is an outlier. And we use the interquartile range, or the IQR, to identify outliers mathematically. So an outlier is defined as any point that lies more than 1.5 times, I should say times, 1.5 times the IQR to the left or to the right. So it's always 1.5 that you're using, 1.5 times the IQR. Our IQR was 8, so I would take 1.5 and multiply it by 8. That number I'm going to both subtract from my lower quartile, Q1, and add it to my upper quartile, Q3, to find if there are any outliers. So here's all the data. We already lined it up. We identified Q1, Q2, and Q3. We already did all of that. We knew that our IQR was 8, because 18 minus 10 gave us that 8. So to look if there's any outliers down here, at the bottom, you take Q1 and subtract 1.5 times the IQR, so 1.5 times 8. The 1.5 is standard, that's always there, that's how we determine outliers. The 8 came from our IQR. So you could put it in your calculator exactly how it's written there, 10 minus 1.5 parentheses 8. Or you could split it up, 1.5 times 8 is 12. So 10 minus 12 is negative 2. That negative 2 is what we're looking for. If any of the numbers in our data is negative 2 or below, then there are outliers at the bottom half of our data. But our lowest number is 5, so that makes no outliers in this direction because nothing was negative 2 or below. But then we have to turn and do the same thing to the top of our data. 18 was because that was Q3. Q3 was 18. Remember, 1.5 is standard, that's always there, and the 8 again came from the IQR. We already knew that 1.5 times 8 was 12. And this time we're adding it to our quartile because we want to see if there's anything up here that is too large. So you add it to go to the right. So 18 plus 12 is 30. If you look at our data, we do have a number that is 30 or above. So that is an outlier. That makes 37 an outlier because it is more than 1.5 times the IQR above quartile 3. So again, you take quartile 1, subtract 1.5 times the IQR, and you look for things at the bottom. Then you take quartile 3, you add 1.5 times the IQR, and you look for things at the top. The last thing we have to be able to do is make a box and whisker plot. You already know all of the information to be able to make it. You have to have what's called the 5-number summary. 5-number summary are the 3 quartiles that we just focused on, and the maximum and the minimum. Okay, so these 3 quartiles we already knew, and then the minimum is just the smallest number, and the maximum is the biggest number. That's your 5-number summary. So to make a box and whisker plot, you find the 5-number summary. And the second step is the most important part that people miss. You have to make a line graph that spans the range of your data. Too many people want to make box and whisker plots perfectly symmetrical. They want to put the box in the middle, and they want to put these little whiskers on the outside and call it good. It's not perfectly symmetrical. The whole point is, where does this box fall in the middle? So the first thing you have to do is you have to make a line graph that spans all of your data. So from your lowest number all the way up to your highest number. Then you plot your 5-number summary on the scale. So you're going to have a minimum, a maximum, and you're going to have your 3 IQRs in the middle. The IQRs are what make the box, and the median makes the line in the middle of the box. And then your minimum and your maximum make your whiskers. So this is the data we've been working with this whole time. I already put the 5-number summary here. The minimum was 5. The Q1 was 10, Q2 was 15, 3 was 18, and the maximum was 37. That's your 5-number summary, okay? 5-number summary. I made a number line that spanned all of the data. So 5 was my lowest number, 37 was the highest, and it is a full number line including all the numbers in between my lowest and my highest. From there, I have to plot all the numbers. So I'm going to plot my minimum at 5. So we're going to put a dot at 5. I'm going to plot Q1 was at 10, so I put a line at Q1. Q2 is at 15, so I put a line at Q2. Q3 is at 18, so I put a line at 18. And my maximum was 37, so I put a dot at 37. Once you have plotted your 5-number summary, you put a box around your entire quartiles. So your IQR basically gets a box around it. Your median is a line through that box. Your minimum is your little whisker out to the left, and your maximum is your whisker out to the right. Notice that this box is not perfectly lined up in the middle of your number line, so that tells you visually that the majority of the data fell down here, which we also proved by saying that 37 was an outlier. You can see it here visually with that whisker so far off to the right. Your assignment for this is posted like it always is in the 2-5 worksheet, but the first page of it was the example that we did in class, so don't worry about the first page. The second page of it says homework, and there are 2 things on there where you need to create box and whisker plots. So find your 5-number summary and make your box and whisker plots.